TD CNC have travelled to Sheffield on behalf of Leader CNC. We've got a bit of a unique machine review today, the Gruppo Parpas Roller XL, and I'm here with Graham at CW FLETCHER. Now, firstly, Graham, thank you very much for inviting us to this absolutely phenomenal facility. Can you give us a little bit of an insight into your company, please?
Well, CW FLETCHER have been around for well over 100 years now, and we're now in the aerospace manufacturing. We're subcontractors to aerospace as well as some nuclear.
So we're looking at this particular machine today. What components are you manufacturing on this machine?
They're basically aerospace rings for a major OEM.
Now, when you were looking to purchase a particular machine to manufacture the engine rings, what were your considerations and why did you choose this particular model?
Well, obviously the primary concern was, first of all, accuracy, but also the uniqueness of the layout of the machine. The kinematics of the machine are in such a way that it allows you access to various parts of the component that a lot of other machines wouldn't actually allow us to get to.
So what kind of capabilities have you got on this particular machine? It's actually a fifth axis machine tool, isn't it, Graham? So can you explain the capabilities of the machine tool, please?
Okay, basically we've got the normal, the XYZ travels. We have about a 2 metre in X, about 1800 in Y and a metre in Z, with a C-axis rotary table that rotates about the Z-axis. We've also got a tilting head that primarily tilts in the A-axis, but it has a special function that allows that head to rotate through 90 degrees. And if you get parts that are where you're reaching the limits of the travels of the machine, we can rotate the head and take advantage of that 2 metres in X. So this allows us to get to parts of the component that we would not normally be able to get to.
So what is the swing diameter of the C-axis on this particular model?
On this particular machine we're looking at 1300 millimetres.
Now that is a huge swing diameter. You can get some very large engine rings onto this particular machine in such a small footprint.
Yes. Normally for this size of footprint you'd normally be looking at much larger gantry type machines, but finding a machine of this quite small size to have the capacity and range was we were surprised that we actually managed to find this type of machine. We looked at various competitors and there were other contenders, but when it came down to it, nobody could offer the solution without adding extra long tools or right-angled heads to be able to realise the tool vectors and get to the parts that we need to machine.
So would you go as far as saying that this machine is pretty much made to measure for the kind of engine ring components that you're manufacturing here?
It's ideally suited to some of the parts that we make. It's not saying that some parts we can machine on other types of machine, but certainly there are some parts that we now put through this machine where it'd be really difficult to achieve that on other layouts or kinematic layouts of machine.
For aerospace critical components that you manufacture here, how important is accuracy and repeatability to you?
Well, accuracy is probably the prime goal. Is that we're constantly chasing those few microns. Part of the process is we extensively use probes for measuring the part, and throughout the process we'll come and recheck the datums and sometimes do an adjust, because obviously we're not in a temperature controlled environment where this machine is, so we have to cater for the fluctuations in temperature. That's not just for the machine but also the parts of the machine and the fixtures. So yeah, it's a constant battle trying to squeeze that extra few microns of accuracy into the part.
But this machine is coping with the accuracy that you demand?
I would say so, yeah.
Now this is a bridge style machine with the C-axis and the tilting head, and you've got lots of capability with this machine, and you can actually rotate the head to get different perspective on the component. Is that correct, Graham?
That's correct, and what's really clever in the way this machine's been set up, it's primarily an A-axis tilting head. That is, it tilts about the X-axis, which is the longest axis. Now, unfortunately, the axis the plane that it tilts in is what is the shortest of the X and Y. Now, and the clever bit is when you rotate that head through an M code, the way the machine's been set up and the kinematic model inside the machine, if you were to write some code or a program for an A-axis machine, you rotate the head and internally it will do all the rotations, and basically you can use it as a virtual B-axis machine without changing any code at all.
So Graham, is it safe to say that this machine is pretty unique?
Absolutely, absolutely.
Now, I've noticed that you're using iodine. How does that benefit you here at CW Fletcher?
In the majority of all our milling pieces of kit, we have iodine controls. And once you're familiar with the iodine environment, it's very easy for an operator to move from one machine to another. And you've got the familiarisation of how the datum tables work, how the tool offsets work. So it's certainly an advantage we try and stick with the same controls for all our milling applications.
So just to summarise, Graham, what would you say are the key benefits to this product?
The key benefits of this machine is really the layout of the machine. It's the accessibility of the features that you can realise with that head that tilts in both directions and goes through the 90 degrees, so we can use it in the X or Y axis, and it's just so flexible that it's difficult to see sometimes what parts you actually can't machine on this type of kit.